Hello, this is Minder Chen. I'm a professor of Management Information System at Martin B. Smith School of Business and Economics at CSU Channel Island. In this lecture, we're going to focus on cloud computing, which allowed us to understand where the IT industry is going. And before we do that, this diagram showed us the kind of evolution of IT infrastructure. Last time we did talk about enterprise architecture and IT infrastructure. In the 60s, it's dominated by mainframe. In the 70s, moving to mini computer. In the 80s, late 70s actually, and early 80s, personal computer appeared. IBM PC was, I believe, brought to the market 81, and Macintosh at 84. But it's more or less a standalone personal computer. It's really personal. It's not networked together or whatsoever. But over time, people find that there is a reason to connect those computing resources so that we can share some common and particularly expensive computing resources like a server, laser printer at that time. And that is what we call client-server computing. So client can be something simpler, and server can be more powerful and serving multiple clients. A signature product in the client-server era will be on the client side. You will have something called graphical user interface called GUI. Such as Macintosh, such as Microsoft Windows, the GUI front end, kind of you running on a desktop, connecting to a local area network called LAN, and it's a typical configuration for client-server computing environment. And certainly there is a kind of a high-end server running. The server can be a more powerful kind of a PC grade computer. It can be actually those mini or mainframe computer hooked up to the network. But then web emerged on top of the internet infrastructure, and the internet, as we discussed previously, was commercialized in 1995. And web was the World Wide Web was invented in 1990, but the popularity started to pick up around 95 and really pick up probably 98. And so you have this so-called internet and connected to your local area network, which may be connected by something we may call it campus-wide network, your enterprise-wide network, and which go through some kind of gateway router hook up to the internet. So people from the internet can get access to system that's offered through various enterprise. So web has been around for almost close to 20 years, if we use 95 as a kind of timeline, 20 some years. And the most recent movement is the movement towards so-called cloud computing, which means we'll explain that, and then which is partially driven by the mobile computing, mobile devices. Because the mobile devices, certainly they become more and more powerful, but at the beginning, it's not so powerful. So we kind of push a lot of computing kind of resources to the server, okay, to network storage device, to a server across the network, across the internet, and that's kind of what we refer to as cloud, to the cloud. And this is also driven partially by something called BYOD, bring your own device. Typically, the IT departments do not like to see people use their own device for security reason. It's hard to manage a variety of devices that people purchase for their own personal use, but they find it to be convenient. They bring it to the office. They want to get access to corporate information system data through their own device. Eventually, at least the trend in industry, the IT departments start to try to support this movement, allow employee to bring their own device. So the concept of cloud computing is not really brand new. It's kind of a buzzword for a few years now. But Scott McNealy, who was the Sun Micro CEO for quite a while in the early day, he actually came up with a slogan called "The network is the computer" probably in the late 80 and early 90. Okay, so here's he kind of reflect on that and say Sun has always been very early and open too early, ahead of its time, with a lot of our ideas. And for example, in here he stated, like at 80, we were preaching that the network is the computer. Okay, and he kind of regretted it that he did not coin the term cloud for cloud computing, just one word, which is easy to catch people's attention and imagination. Okay, cloud, you can do a lot of things on the cloud. It just sounds much better. But why we call it cloud? Okay, because when you draw a system architecture diagram, this symbol, which looks like a cloud, is often used as a notation to represent a network. Okay, so cloud computing, basically you can consider that's kind of the network computing or sharing computing resource over network, including internet. That's kind of the concept of cloud computing. One of the key component for cloud computing, which as an end user we may not see that much, is what we call virtualization. Okay, virtualization. Before we talk about virtualization, let's first look at what virtualization technology try to solve. In a survey by economists, survey on IT, they found that the number of data center, huge data center running a lot of maybe mainframe mini computer servers, has a bunch of them in America. Guess how many we have? 7,000. Okay. However, if you measure the percentage of utilized server capacity on average, utilized, okay, just like your CPU, you may only use 30% of the capacity if you're just running some simple program. If you run heavy-duty engineering computational thing, it may utilize 70-80% of the capacity of your CPU. That's what we call utilization. Only 6%, extremely low, waste of the computing resource, which means waste of money. Why? And you may ask why this happened. This is why. The demand for computing resource fluctuate up and down. Okay, this is not in computing industry. In a lot of industry, the demand may fluctuate, and actually the supply may actually fluctuate. But in the traditional computing IT infrastructure, the the supply side, which our capacity is not so flexible. Okay, you pretty much has to have a fixed capacity in order to meet the peak demand. So on average, maybe that's what you need. But since your peak is here or even potentially here, you actually need to build up your capacity this high. And because of that, you waste, on average, you waste a lot of your IT resources, which is sitting idle, not doing anything. So that's why here we say over provisioning. Provisioning means providing IT infrastructure to the user. Okay, it is really a major waste in the IT industry. Okay, you're talking about space, you're talking about power, and then manpower, and the electricity, cooling system, etc. So without virtualization, the utilization can be very, very low. Okay, and we're running multiple servers, usually dedicated for one application or application server at a time. Require power, heating, cooling, emit heat. That's why we need cooling system. Require physical space, setup, configuration takes time, maintenance, support, require a lot of smart system administrator. If we actually have a more powerful server and use the virtualization technology, VMware is one of the virtualization vendor. They provide a virtualized layer which allowed us to run multiple servers on a single platform. And so it's easier to manage, and also all those servers are kind of virtual server being virtualized. You can easily back it up as an image file. If you need to reinstall it, you just copy the image file and run it on top of this VMware virtualization layer, and then you got a server up and running. So in terms of provisioning, it's really, really convenient. The administration is convenient, and you reduce, and also the fluctuation of the demand for various applications kind of even out among those application servers. So to some extent, it's you can utilize your computing facility with higher utilization rate. Okay. So here we mention flexibility, rapid provisioning, disaster recovery, high availability. We can automate this process of deployment of a new server based on the existing configuration, just copying an image file. NIST has actually a well-respected and very specific definition of cloud computing. NIST is National Institute of Science and Technology, which is part of the Commerce Department at the federal government. It's located, the headquarters is located at Gaithersburg, Maryland, near Washington, D.C. The definition states that cloud computing is a model for enabling convenient, on-demand network access to a shared pool of configurable computing resources, which could be network, server, storage, application, or services, whatever that imply. Can be rapidly provisioned. You can quickly ramp up and ramp down. Okay, and release with minimum management effort or service provider interaction, which is pretty much you can self-service, automate a lot of things. So there's ability for the end user to utilize part of the share and bulk resources, which is supposed to be cheaper, and to use it. Okay, or they can certainly use the whole resources the way they want it. So they identify several characteristics based on that definition. First has to be on-demand self-service, which we mentioned. Network access, broadband network access. You do need the bandwidth if you use cloud services. Resource pooling, resource sharing. Put resource together so multiple customer client can share it. Okay, so we don't charge individual client that much because they're sharing the resources and they have a different demand curve which even out each other. Okay, that's kind of a perfect situation. Rapid elasticity. Elasticity just means we can really cope with demand peak by rapidly deploying the computing resource as needed. Okay, and sometimes we call this utility computing or on-demand computing. Okay, based on this rapid elasticity concept. And the service is so-called measure service, which means that we can measure how much resource you have used and then charge you according to what you use. Okay. If you have slow day, not using much, you would be charged less. If you have somehow just placed, for instance, a Super Bowl ads and people are hitting your website like crazy, the system will scale up and handle that peak traffic. Okay, and solve the problem that we had previously. So the platform, traditionally, it's kind of on-premises server. You build your own, you own it. You need to kind of invest in your own infrastructure, host it. Someone else will host your server. You can share the server a little bit, but usually they're not that flexible. Okay, you still pay for fixed capacity, even if it is idle. Okay, you have less control over those resources. The cloud platforms shared multi-tenant, which means multiple customer infrastructure, usually use virtualization and can scale easily. And we have an abstract layer, which is the virtualization layer from the underlying infrastructure, which allowed us to port the image file to different environment. And it's pay as you go. Pay as you go according to how much you use. Okay, so that's cloud computing platform. So there's a whole spectrum. A lot of time people refer to cloud computing. They may be actually referred to just hosted server. Okay, in my humble opinion. There are some concern about security or privacy, and that's why some company may prefer to have a so-called private cloud. The private cloud, you build your own infrastructure, you do make it available through the network and control the access to it very carefully. But a lot of companies take a kind of middle road approach, and they use partially some public cloud, external cloud, and certain functionality will run on their private cloud for security reason. And that's called hybrid cloud. In this complicated diagram, from consulting firm in general, could be Gartner, I believe, where I got this, that classify cloud computing into three. Typically we see three, but here we have like 4 tier or 4 layer. At the bottom is infrastructure as a service. Okay, you need a server running just a bare bone, maybe just certain hardware, main memory, whatever. Amazon will give you Amazon Web Services, okay, called AMS. That may involve the underlying operating system, okay, but the server would connect to the network. There's a storage. a higher layer you move to from infrastructure as a service, you move to the platform as a service. So you're running on a particular IT platform. You're running Windows Server, Linux server, Unix servers, you name it. Okay, maybe it come with a specific database like SQL Server under the Windows environment or MySQL, and they may come with some development tool. Okay, Google's app engine is an example of it, which is not really that well known, relatively speaking. When you move up one more layer, and by the way, those are usually used by developer. Okay. Application as service, this is where the end user, true end user, may consider to use an application package like Salesforce.com, which we may have or will discuss in part of the CRM discussion. And you don't have to buy software. Basically, you're renting software. It supports various specific business function, CRM, ERP, HR. Salesforce is known for its CRM area. Financial application, collaboration. That's called application as a service. One level up, which is kind of new, called business process as a service. Okay. We're providing industry-specific service, like your retirement, handle your benefit, your retirement money investment, okay, handle your business travel. They may still use actually some web-based application, the application as a service, but it's on the provider side, okay. And you can make a phone call, you can get on their website, they will handle a particular business process for you. And later I'm going to just describe Fulfilled by Amazon, which is Amazon's kind of new offering at this layer. A lot of cloud-based storage kind of services, Dropbox, Google's Google Doc, Microsoft's SkyDrive, Amazon's Cloud Drive, and Apple's iCloud, to some extent, all are kind of cloud-based storage, which means no matter where you go, as long as you hook up to the internet, sometimes you may need to download a particular client-side piece of software, but there's always a web-based access to it. And then you can actually get access to whatever data you store on the cloud or share it with whoever you want to be over the cloud. So it's quite convenient. A lot of them will offer you something, some like 2 GB of memory storage space for free. And then if you want more, and you need to pay for it. Last, let's just use Fulfilled by Amazon example. This is one of the Amazon's program. You can go to Amazon's website here and check it out. Okay. In this case, Amazon is not selling you any computing resources. They're selling you their warehousing and distribution services. If you have a product you want to sell through Amazon, under this Fulfilled by Amazon banner, you ship your product to Amazon. Amazon will store your product at their warehouse. When customer can find and purchase your product, Amazon will handle the order fulfillment, pick and pack the product, and ship it to the customer and collect the money and eventually pay you. That's great. You say, well, I'll use it. Okay. The only thing you need to be aware is that this is not free. They charge you for storage fee. They charge you for order processing and handling fee, etc. Okay. But if you don't want to manage your own distribution facility, warehouse, this is a viable option. Okay. Some may argue, well, distribution could be the competitive edge for Amazon, and why they want to share that with other people, okay, other vendor. And by the way, most vendors are small vendor. They just couldn't afford to have a warehousing facility. And Amazon willing to share that, so they got more user. When they got more user, they got the economy of scale, which means per, let's say, square footage for warehouse potentially would drop. It benefit Amazon itself to pay less because of the scale. They per unit cost for storage and distribution may be less. And also they're making money by providing this service well. So this is a very unique and innovative kind of service. We call it business process as a service example. Okay, check out Amazon's description of the service and see whether you may be actually interested in using it. Okay, so thank you for listening, and for this segment of the lecture on cloud computing. It's kind of a very exciting, still a moving target right now, but hopefully you get a good handle on it based on my explanation. Okay, thank you for watching. I'll see you next time. Bye bye.